Welcome. This is the first segment of this course. We roughly titled it Systems in Humans, and we'll talk a little bit about where AI and software come into a medical application. What do we mean by systems? How do humans interact with systems? What does it mean for a human to be part of a system? We're going to ask all of those questions and more as we think about medical AI, medical software, of course in the context of medicine, in the context of healthcare. So this section is like an introduction to the whole course. My name is Xenofon Papadimitris. I'm a professor of biomedical informatics and data science at Yale, also in radiology and also in biomedical engineering. I have a few other administrative roles here, and I direct this program. So when we think about the system, one good and easy example of a system is that of a walled city. And if you have to pick one, and your hometown is a walled city, so I'll pick my hometown. I grew up in a little island called Cyprus. This is a map of the greater Middle East. And if you zoom further, the city of Nicosia, or Lefkosia in Greek, is right in the middle of the island. And the city of Nicosia is a walled city. It looks like this. This is a schematic from 1570. This is the year before the Ottomans conquered the city. They have been ruled by the Venetians. So this is a schematic of the old Venetians' walls of the city. And if we think about the city as a system, we have the inside, the area inside the wall. That's our system, the region we care about. We have the outside part of the wall, the things that are beyond the wall. That's the environment. Now, of course, that is the modern city of Nicosia, but back then it was fields. And then if you look at a picture, this is a picture of the wall, we have interfaces, the places. Here's a gate here where information goes in and out. So this is Famagusta Gate. It's on the southern eastern part of the city, actually close to where I grew up. And so a city consists of an inside, an outside, and the ports, the interfaces through which we get people, goods in and out. And in the case of a computer system, that's how we get information. Now, where does AI come in a system, in a software system? And AI is one component. So AI lives inside the system, is a part of a software system. It's not a standalone thing in medicine, typically. It's just a component of a larger software system. So think of AI in this extended analogy of a walled city as, an important building in a city, an important function of a city, an important component of the city, but part of a larger city. And so if we keep extending the analogy further, think about perhaps AI in a system or AI in a piece of software as something along the lines of the engine inside the car. So maybe the software, the overall system is the car. You see a particularly ancient picture here on the right. And the AI might be this piece here, the engine of the car. It's a critical part of the car, but it's not the car. And if we ever remember anything about this course and anything we talk about is that users drive the car and they do not drive the engine. People think they drive the engine, but what they really drive is the car. So what you have is, if you look out your window, presumably if you're above a main road of some kind, you see lots of cars driving down the street. You will never see a naked engine. And that's an important lesson when we think about AI. We think about systems, we think about cars, not engines. Now, a better engine will make for a better car, but even a great engine may still be part of a terrible car if it has other issues. And so the engine is critical, but there are other things that affect the user as much as the engine. So things like the brakes, transmission, seats, comfort. And the solution to issues such as bias, safety, security, the whole host of issues that we'll talk about over the next 15, 16 weeks, may not always be better AI, but frequently better system design. We may not be able to solve the AI problem. We may not be able to make the AI have no errors. So our solution may be risk management or some other kind of mechanism that may have nothing to do with AI. So let's stretch the analogy even further. We have that system here, the inside, the outside, the AI somewhere in there. We took it out for now. And now we have humans. So consider the picture on the right. This is a radiologist, AI-generated picture here. You see a radiologist looking at a computer screen, perhaps trying to look at lung nodules. We'll see an example of those later in the course. And so the question, if you look at this picture on the right, and you think of the picture on the left as a schematic, is where is the wall? What do we think is the system? So your first answer as a software engineer is to think of the wall as that red oval there. The computer, the software, is the wall. The human is outside the wall, and the human looks at the computer through an interface, through a gate. Perhaps this is the equivalent of the screen here. The human is outside the wall and communicates with the system through an interface. Through a user interface in this particular case, looks at a screen, touches a keyboard or a mouse. And that's one view of the world, and that's how software engineers are trained to think. But perhaps there's another way to think about it, and that is the yellow box. And the yellow box now puts the human inside the system, And what's outside? Outside is the patient. Outside is the rest of the hospital, which communicates with the yellow box through perhaps electronic health record, receiving a report, through an email, through conversing with the doctor later. So the system in this scenario consists of the human plus the computer. And I submit to you that this is primarily how we should think about medical AI. Medical AI or a medical AI system is really a combination of a human plus a system, or what sometimes we call a socio-technical system. A system consists of technology and a human component. And if you think this is a weird, unique approach to us, let's go back to a guidance document that came back out in 2021. This is jointly issued by the FDA here, the Canadian Regulator Health Canada, and the Medicine and Healthcare Products Regulatory Agency. This is the UK regulator, and these are the 10 good machine learning practices for medical device development, if you include AI, machine learning. And one of the items on their list is focus is placed on the performance of the human AI team. So what these regulators were telling you back then, and this has stayed as a theme in subsequent guidance, we'll see some of that next week, is that the system we're evaluating is the human plus the computer. And that is because that is where the diagnosis for the patient comes from. That is what provides the health care. It's not the computer alone, it's the computer plus the human.